Good morning. Today we are starting an important topic in artificial intelligence. It's a knowledge representation. Whenever we talk about building AI systems that are truly smart, it's not about just processing data. It's about how a machine stores, organizes, and reasons with its knowledge, so it can make an intelligent decision. Understanding knowledge representation is essential if you want to build systems that move beyond simple patterns, matching to real reasoning and understanding. In today's era, each and every intelligent system it uses the knowledge representation. Let's begin with the basics. Knowledge representation (KR). It describes how we store and structure knowledge so that computers can reason and learn and make decisions. There are a few types to know. First, declarative knowledge. Second, procedural knowledge. Third, meta knowledge. In declarative knowledge, it's a fact about the world. Statements like Paris is the capital of France or water boils at 100 degrees Celsius. Second, procedural knowledge. How to do things like following an algorithm for solving a Rubik cube or cooking a recipe called procedural knowledge. Third, a meta knowledge is a knowledge about the knowledge, rules for how to use or update other knowledge. In artificial intelligence, KR helps us represent real world information in a form computers can use to answer questions, solve problems, and communicate with people or other systems. What are the key goals of knowledge representation? So why is the knowledge representation is crucial? First, we need to represent the real world in a computable form, so machine can truly reason about things around it. Second, it should enable reasoning and problem solving, not just storing info but using it to make deductions. It also helps facilitate communication between different software agents or between people or even between machines. For example, if you want to a robot to clean a room, it must know the layout and obstacles and its own abilities and represent all this internally to plan and act. Knowledge-based agents. So what's knowledge-based agents? An agent in AI is something that perceives its environment and take actions. A knowledge-based agent uses a structured knowledge base to reason about its environment and make decisions. Here's how it works step by step. It includes four steps. Perceive environment. Here, the agent uses sensors to observe its world or its environment. Second, update the knowledge base. The agent adds new information to its memory. This is often called tell operation. Third, infer new information. It using logic, it deduces new fact from what it knows. This is ask operation. And finally, decide and act. It's based on what it knows and has deduced. The agent chooses an action and carries it out. This is the foundation for all advanced AI. Collect data, build knowledge, reason about it, and then act intelligently. The classical example for knowledge representation is called Members World. Let's make it more interesting. Imagine a game like environment called Homer's World, a classic AI test bed. The agent moves through a grid-based cave. There are dangers like pits the agent can fall in, a monster called Wumbus, and then the goal is to find the gold. This is our objective. The agent has to use clues like breeze, indicate a nearby pit. Next, stench indicates worms nearby, and the glitter, it tells you gold is here. To make a decisions, often with uncertainty. The agent goal is it use logical inference based on these sensory clues to safely reach the goal and exit alive, avoiding the worms and the pits. This example shows how knowledge representation and logical inference are crucial for reasoning under uncertainty. Propositional logic. One popular way to represent knowledge is called as propositional logic. Here, information is represented as simple true or false statements called propositions, like it's raining or the ground is wet. You can combine these using logical operations like not, and, or implies. For example, let's P equal to it's raining. Let Q equivalent to the ground is wet. If it is raining, then the ground is wet. Becomes P gives Q. Propositional logic is simple and efficient for small domains, but there are trade-offs. We are having a limitations also. It can't express more advanced relationships, like every person is mortal. For that, we need more powerful system. Inference rules. Propositional logic supports automated reasoning through these rules, like modus ponens and modus ponens, modus tollens. If P gives Q is true and P is true, then Q must be true. This is a ponens. If P gives Q is true and Q is false, then P must be false. This is called as a tolerance. For example, if it rains, then ground is wet. P gives Q. It rains P, so the ground is wet Q. These rules allow AI systems to deduce new fact from known information, which is the art of knowledge-based reasoning. First order logic. To overcome propositional logic limitations, we have FOL called first order logic. FOL introduces objects, relations, and quantifiers. So it can represent more complex statements like all humans are mortal. The key elements of this FOL is one is a constant, second predicates, third functions, and finally quantifiers. Constants, it represent specific object like RAM, KIT, predicates. It describe property and relationship. Student X loves big data. Functions map objects to other objects like student Y associated with data science. Finally, quantifiers express generality. For all A, there exists E. In this example, it reads as for all X, if X is a human, then X is a mortal. This is called as a first order logic. This is much closer to how humans naturally express rules. Syntax versus semantics in FOL. When working with logic, it's important to know the difference between syntax and semantics. Here, syntax, the structure of valid sentence, like what combination and formats are allowed in our logic, called syntax. Semantics, the meaning. What do this sentence actually mean about the world? For example, Love, John, big data is a syntactic valid. Semantically, it's only true in words where X actually loves big data. To use logic efficiently in AI, you need both correct structure called syntax and the knowledge that matches the reality called semantic. Advanced knowledge representation concept. There are more advanced topics you will hear about in AI called situation calculus, ontological engineering, truth maintenance system. Situation calculus, it's a way of reasoning about changing worlds, like tracks different situations over time, over action and their effect. Useful for planning and robotics. Second, ontological engineering, building a formal ontologies or structured vocabularies. It helps machines understand domains like medicine, manufacturing, or even the web. Third, truth maintenance system, help artificial intelligence systems keep their beliefs consistent when new or conflicting information arrives, automatically updating conclusions when something in the world changes. These concepts are the foundations of advanced applications like semantic web planning and adaptive artificial intelligence systems. These are all the key takeaways. To summarize the main points of this class, first, knowledge representation. It lets machines store, structure, and reason with the information, not just store it as raw data. Second, logical systems like propositional and first order logic. It provides a formal basis for encoding knowledge and performing inferences. Third, knowledge-based agents. It uses this encoded information to act intelligently, combining perception and logical reasoning. In a dynamic domain, the techniques like situation calculus and truth maintenance keep AI beliefs up to date. Ontological engineering, it enables machines to share and understand complex structured domain knowledge, crucial for real world or large scale artificial intelligence. Remember, every intelligent AI system, from a chess agent to a self-driving car, depends on effective knowledge representation and reasoning. Thank you all.